Hello everyone, welcome to Almighty Tricks. In this video, we'll be understanding about factory design pattern. So first of all, we'll see the definition, then we'll see where we can use the factory design pattern, then we'll see the practical example. Okay, let's start with the definition first. So the definition is saying it helps to create the factory design pattern helps to create objects of the correct subclass. Okay, so it is saying object of the correct subclass. Let's suppose I am a customer of this television shop, okay, where I arrived to buy a television. Okay, so I asked shopkeeper for either a Samsung TV or MI TV or Sony TV. Okay, the shopkeeper will analyze my request. My request means what I asked for. That request he will analyze and he will find which television is I am asking. So I asked for the Samsung TV, MI TV, and Sony TV. So he will see where is the Samsung TV is present, where MI is present, where Sony TV is present. So based on my request, the shopkeeper will decide and he will give the television. Okay. So here basically it is the shopkeeper is nothing but a factory. Okay. So based on my request, shopkeeper is deciding which TV needs to be shown. Okay, so here customer is the client and shopkeeper is the factory. So factory is deciding which the television needs to show based on the client's requirement. Okay, so let's understand first where we can use the factory design pattern, then we'll see the practical example. Okay, so if you see there is a scenario, let's say there is a scenario like based on some parameters or condition you need to create the object. In that case you need to use factory design pattern. Okay, so here if you see the example, so I am giving one request. I am giving some parameters like it should be a Samsung TV, it should be a MI TV, it should be a Sony TV. Based on my input, this shopkeeper is deciding which object or which TV or which television needs to be shown to customer. Okay, so wherever you are seeing the condition or some parameters are there, you need to create based on the parameter you need to create the object. In that case you need to use the factory design pattern. Okay, that's simple. Okay, let's understand with a practical example. So here I have created one factory package. So the motive of this example will be, so I need to send some notification via email and SMS. Okay, so first of all I'll design this application without using factory design pattern. Then I'll explain the demerits of that design. Then I'll start writing the code using factory design pattern. Okay, so let's start with without having the factory design pattern. Let me create one class, that is SMS notification. Let me have one method called public void send, from where I can send the notification via. Let me put the print statement, send notification via SMS. Okay, let me create another class, email notification. Okay, so here also I can have one method, public void send method, and from here I can send a notification via email, send notification via email. Okay, now let me create one client class, client. Let me have the public static void main. Okay, now let me send notification via SMS. So for that I need to create the object of notification, SMS notification class. Now I need to call that method, send method. Now let's say I need to send notification via email also. let me put the email notification object here. Okay, then I'll call that send method. Okay, if I run here, so both the notifications are working. Okay, let me correct this name. Okay, so the issue here is in client class. So in the client class, we are using SMS notification and email notification, which are tightly coupled with the client class. Okay, the good design is like, as much as possible we should support loose coupling. Okay, but here it is supporting the tight coupling. Okay, so another issue is here we are creating the object SMS notification object and email notification object in the client class. So here basically we are kind of exposing the object creation technique to the client. We should not we should not expose the object creation technique to the client. We should have some abstraction. Okay, so for that we need to create the factory. So let me create one interface here. So I can use interface or I can use abstract class. Let me create interface here. Let's say I notification interface. In this interface I can have one method that is send notification. Okay, then what I'll do, I'll use this it should be interface. Okay, okay, and I'll do this notification interface I'll implement from email notification and SMS notification. Okay, here I need to override that send notification method. Let me copy this print statement. Let me remove this. Then from SMS notification also I need to implement iNotification. Let me override that send notification method. Let me copy this print statement. Let me remove it. Okay. We have created one abstraction layer in between the client and the actual code. Okay. So now let me create one factory class, notification factory. So this notification factory will have the logic to create the object. So let me create one method public. I'll come to this return type later. Okay, then create object. Okay, so I'll take one parameter. Based on the input we'll create the object string type. Okay, so I can have switch case or I can have if condition. So type dot equals, let's say, SMS. So if it is SMS, then I'll return new SMS notification. Again I'll check else if type is as email, then I'll return new email notification. Okay, otherwise I'll throw one runtime exception. I'll provide one message, provide correct type. Okay, so here we are getting this error, right? Because we haven't provided any return type. So the return type should be IE notification, right? Okay, so let's go to the client class. In the client class, let me remove all this thing. So from here let me create notification factory object. Okay, now what I'll do, I'll pass some input. Based on those input, it will create the appropriate object. Let me call this notification factory dot create object. Let me create the object for email notification. Email. Okay, let me save this. Let me run it. Why it is not coming? Let me check. Create object. Okay, we are getting the object. Okay, so we need to store and then we need to call. So it will return the I notification type object. Then we'll call the send notification method. Okay, let me run it again. Yeah, now I'm getting this send notification via email. Okay, let me create SMS object, SMS notification object. Let me run it. Yeah, I'm getting send notification via SMS. Let me provide some wrong type XYZ, let's say. Let me run it. It should give the runtime exception. Yes, it is giving the runtime exception. Okay, so this is the basic example of factory design pattern. Let me show you in the diagram. So diagram is showing like this. So we can have client and we can have one abstraction layer, or we can have one interface. That interface can be implemented by SMS notification and email notification, and we can have one notification factory. In notification factory we can have the logic to create the uh, appropriate subclass object. So it will create based on the type provided by the client. The advantages we are getting here, like we can hide the object creation logic from the client. Okay, and we can achieve the loose coupling using factory design pattern. So previously it was tightly coupled, now it is loosely coupled. And so this type of design, factory design pattern, is called practical factory design pattern. There are two more factory design patterns are there, and those are like factory method design pattern, abstract factory design pattern. Okay, so these two design patterns are not frequently used in present days, so will not be covered. So if you want the detailed video of those two design pattern, let me know in the comment section. So I'll prepare one video. Okay, so hope you understood this factory design pattern. See you in next video. Thank you for watching.